trains operate year-round with the main purpose of transporting goods and people. Canada's system of railways connects hubs across the country over sparsely populated areas and are a vital part of the infrastructure. This means that any downtime will significantly impact the rail company's revenue and the delivery of critical goods and services. One of the most significant causes of rail delivery delays are derailments. Every day across North America, we see an average of 3 derailments. Some are relatively minor and can be repaired in a matter of hours, while others can be significant, causing days, even weeks of delay, damaging the environment, or worse, causing death. To mitigate delays caused by these derailments and other railway infrastructure issues, rail lines are typically inspected using high-rail truck-mounted sensors or, in many cases, simply by manual methods. Not only is this a rather tedious and time-consuming process, it also means that while inspections are going on, nothing else can occupy the same section of track.
That's how we inspected rail inspections on the high rail. And when time permits, we do walking inspections where we're on the ground looking for ties, broken bars, bolts, and then go in behind to fix it later.
Well, one of the biggest things is time. We really could use the men working on the track rather than inspecting the track. If we could get the track inspected by drones, so much time saved. It'd be great.
In order to make the inspection process safer and more efficient, DecisionWorks has developed a revolutionary software called TrackSense. This software automates the rail inspection process by integrating with already available drone platforms. These include fixed-wing drones for the inspection of long stretches of rail and quadcopters that are better suited for short-range operations of small sections of rail, performing volumetrics or capturing 3D imagery in support of bridge and other rail infrastructure inspections.
When we have a fully autonomous flight, what that allows for is any responsible crew member to be in charge. So being able to have a certified operator nearby, someone's easily trained, a visual observer, you can now use that horsepower, that human intellectual capital, spread it across your project. You can get more done, you can measure more, you can get things done much more efficiently, and overall you can have a much better readout of your project. And you tie that into everything that Grant's doing with TrackSense. You're not tying up all that capital in one role.
The primary goal of TrackSense is all about safety, but increasing profitability and ensuring ease of use come at a close second. TrackSense completely automates drone flight operations, meaning the operator is only tasked with scheduling the mission and releasing it at the designated takeoff and landing location. The missions that are created can be saved for future use, making the capturing and comparison of data over time easily repeatable. While in the air, the camera payload of the drone captures images that are later processed for examination and data analysis. With these different aerial platforms, miles of track can be covered in a matter of minutes. This results in safer working conditions for the rail inspector, less time on site, and ultimately a better view of the track itself for closer analysis by multiple parties. With a digital replication of the landscape, anyone with access to an electronic device can instantly get the same or better perspective of railway infrastructure as if they were visiting the site themselves.
Yeah, so they've got a pretty unparalleled level of expertise in both drones and railways. Kind of hard to find folks that are bridging those two gaps. And the software stack itself is integrative in the sense that it works well with both and brings data in from a whole variety of sources and makes meaningful use of them. There's also the obvious, which is that they work in pretty near impossible environments. It's -40, wildlife is a problem, emergency response is hard to come by, and they're able to pull off really complicated, sophisticated things in those conditions regularly and reliably.
The power of TrackSense is on full display after the processing of the images has completed. Being able to zoom in and see precise details, view the area as a 3D model, take measurements, and generally assess the conditions of the railway makes for an effortless inspection process. Through the process of flying the railways, not only does TrackSense shorten the time spent on site, but it gives rail companies access to tools they didn't have before.
Everything was great. It was an awesome time. I really enjoyed the sights and sounds of the drone and the drone, what they can do, how quick they can get up in the air and over a piece of track and back, and you're gone again, back in your vehicle, moving to another spot. In and out of sites, doing volumetrics testing, and also looking at track structure itself, ties, gauge, surface,
Railways are an extremely vital piece of the global economy, transporting large amounts of goods from place to place and getting passengers where they need to go efficiently. Inspecting the thousands of miles of tracks across rural areas that can experience extreme weather conditions is tedious by hand, but with TrackSense, it can be accomplished safely and efficiently.